share my screen now. 1 second, let's just start recording. All right, perfect. So recording has started. I'll start sharing my screen. Okay, so after we finish discussing the functions and we took the function from different perspectives, different points of view, we covered everything related to functions. We talked about the 4 types of functions. We'll start now with a new topic, which is arrays and pointers. Why we need arrays and what are the arrays? And the pointers, of course. First, we'll talk about the arrays, then we will talk about the pointers. So let me start just with general discussion. Now, suppose that you want to read, to read 2 numbers and read 2 numbers and find the average of them. All right, so that means I will write in the main function like 2 real number. Let's make it real number. Double or float. Okay, double x, and I will separate them, and double y. We can give the value, no need to cn, etc. So double x equals 5 point something. Double y equals 7, for example, and I'll define double average equals x plus y divided by 2, right? So that's it. It's an easy task, right? Now, if I change the program and make it read 3 numbers, 3 variables. Now I'll do the same thing for 3 real numbers. All right, then all what you do, you'll define double x equals 5 and double y equals 7 and double z equals 8, for example, and then double average equals x plus y plus z divided by 3. All right, I'll continue. Now with 4, what will you do if I ask you for 4 variables? Of course, you are thinking of creating the same thing like a double A1, A2, A3, etc., or X, Y, Z, W, etc. Actually, this will not be feasible if the number of variables, this is for me, if the number of variables more than 3, okay? But let's think of something which is very important here. See, what's the common thing between the variables? Okay, let's think of the common thing between the variable. You just take a look and let me know. Did you notice something? That all the variables are of the same type. So I can collect them, put them all together, okay, in one variable and give it some name. All right. This is what or the basic idea of arrays. Arrays actually in mathematics, if you remember, in mathematics you studied something called vectors and matrices or matrix, right? If you remember, in vectors you used to put values 1, 2, 3, 7, etc. And in matrix it's two-dimensional array like 1, 2, 3, 4, 5, 6, 7, 8, 9, or any numbers. All right. So the same idea here we are applying with the programming, and we call it array. So instead of having double X and double Y and double Z, I'll be having one array that includes everything, all the three variables. I'll call it, for example, double. Give it any name, like A of 3. Okay, and I can now put A of 0 equals X, and A of 1 equals Y, and A of 2 equals Z. So instead of declaring or defining three different variables, I can declare only one variable with this called index. Okay, with indices, and I can refer to them based on the indices. This is the main idea, or the easy, or the clear picture of the array. So after we talked about this idea, let's go and see the programming structure, or how to declare the array, how to use it, etc. All right, so now the arrays. Consecutive group of memory locations. The meaning of memory locations, of course, here you have the memory. Okay, so we will reserve memory locations for an array. I will show you how, but after we read this. Same name and type. So, for example, in this case, I'm booking now or reserving for an array, okay, of 5 of type integer. All right, the size, this is the size, this is the type, this is the name, and this is the size. 5 memory location, depending on what? Depending on the size of the variable, of the type. For example, an integer, I will reserve 4 bytes for every integer, but let's consider that every location is divided into 4 bytes, and that's it's beyond our discussion now. So here, if I'm reserving or I'm starting or declaring a variable called nar, an array, okay, of 5. That means I'll book the first location for nar of 0. Remember that, or always remember that we start the array from 0. So if it's of 5, that means the maximum will be 4. Okay, the next one will be in array of 1. The next one in array of 2. The next one of 3. And the last one, of course, we can continue with the memory, of 4. Okay, an array of 4. So if you can see here, 0, 1, 2, 3, 4. But when you count them, you will find this is 1, 2, 3, 4, 5. So I reserved 4 locations. You have to differentiate between two things, the index and the number. All right, here I have reserved five location, or booked 5 location for the array, but the indices start from 0, 1, 2, 3, 4. So this is one of the things that you need to pay attention. So if I tell you, like, what will be the value of the 4th element fourth element. That means I'm searching for the fourth element in my way of calculating. So I will count this 1, 2, 3, 4. The index will be 3. So you will write in AR of 3. All right. OK. To refer to an element, specify the array name and position. So if you want now, if I tell you to print or see out an array of this, you need to refer to the name of the array and the position. The position is 3, but it's the fourth element. All right. Now format array name and position number. OK, first element at position 0 always start with position 0. All right, so don't start counting from 1. You have to start from 0. An element in C array. If I have an element like here in our example, I have 5 elements. That means the indices will be 0, 1, 2, 3, 4, no 5. OK, don't write 5. So if you count them, 1, 2, 3, 4, 5, but it starts from 0 to n minus 1. If the number is n, then n minus 1. Array elements are like normal variables. You can use them as normal variables. Just like the previous example here, instead of declaring x, y, z, okay, we will declare, of course, we will implement this. I will declare, for example, double. Okay, I'll call it A of 3 equals, initialization, usually we use this, 5, 7, and 8. Now, the meaning of this, that I have declared 3 variables, A of 0 equals 5, A of 1 equals 7, A of 2 is equal to 8. So if I want to find the average, equals, of course, later we will use counter, but now, since it's only 3, we will use this A of 0 plus A of 1 plus A of 2 divided by 3. This is the average. OK, so if I have any number of elements, I can use the arrays to store the variables with the same type. I cannot store integer and double in the same array. Everything of the same type. OK, so here we found the average and we can access anything. Of course, if you write A of 3, just like this one, this will be error. OK, why? Because in declaration, A of 3 means I have 3 elements, but in programming and instructions, when you use A of 3, that means access the fourth element of the array, but we don't have fourth element here. We have only 0, 1, 2, 3 elements. So A of 3 means the fourth element. OK, all right. So getting back to our discussion, you can use them. You can change their values. You can use them in mathematics, etc. OK. The best way is to start an example, or yeah. OK, so let's here remove this. This is object oriented and okay. All right, so here I have, as we said, I'll declare double x equals 5, y equals 7, and z equals 8. All right, and then double AG equal x plus y plus z divided by 3. And of course, if you want to print see out the average is AV and line. All right, and now I can execute it. This is without array. Okay, so I will write it here as a comment. Code without using arrays. All right. Let's run it. All right, built successfully. Then I can run it now. Window, all right. Okay, so this is the average, all right? But as I told you, what if I have more variables, like I have 10 variables? Will I keep naming them? How to know that they are the same? So an easier way to do this, I will do the same code, but with array. Here, instead of having double, see, I remove everything here. I will define an array of 3 equals 5, 7, and 8. Now I don't have X, Y, Z here, although still accessible, but I don't want to here with. Okay, I don't want to separate the code. That's why actually these are two different programs. Okay, so here if I want to find the average, I will write A of 0 plus A of 1 plus A of 2. All right, divided by 3. Okay, we'll get the same answer, I'm sure, if we are using the same number. Let's run it with errors. AV already defined, so I don't need to declare it again. Okay, so successfully I will run it. All right. Okay, so the same gave me the same answer here, but with different approach. So this is just for execution or for implementation matter, but in your lecture I will the code separately. So let me just add them. Okay. Okay, here I will put the first part without using array, and also I'll bring the other one with using array. Okay. These are two different programs. All right. So without using array, you have to declare or to define a lot of variables, and you have to use them like this. And with using array, you need to declare only one variable, but with different indices. So we'll get back to our discussion. Okay. I hope the idea is clear, right? We'll get back also again to have more examples. Okay. So, as I said, and the idea of these programs to code segments is to find the average of 3 real numbers. This is solution number 1. This is solution number 2. with array and without array. Okay, so let's get back. Example using arrays, initializer. See, actually here, integer n of 5. That means I have n of 0, n of 1, n of 2, n of 3, and n of 4. If I count them, 1, 2, 3, 4, 5. All right, so equal 1, 2, 3, 4, 5. Okay, that means n of 0 is equal to what? This is the index 0, 1, 2, 3, 4. All right, so n of 0 is equal to 1, n of 1 is equal to 2, n of 2 equals 3, and so on. All right, so in this case, when you declare any number of variables, you have to differentiate between the index or the indices and the sequence of the number. If not enough, initializer, rightmost element becomes 0. What does that mean? Let me just show it to you practically. Now, in this case, I will remove this code. Okay. Then, if I define this array, okay, and see out a of 0, okay. Although I prefer to use the for loop, but not now. You know, there's an easier way to print everything using the for loop. Okay, a of 0, endl. Right, I'll print a of 0, a of 1, and a of 2. 1 and a of 2. Okay, let's run it. All right. Okay, so this is what we got. 5, 7, and 8. That means we printed a of 0, which is 5, a of 7, a of 2, 1, which is 7, and a of 2, which is 8. Now, if I have larger one, let's assume that I have 4, a of 4. That means, or a of 5 even, okay? And I continued with the 2, 3, and 4. I don't have 5. Why? Because the size of the array is 5, so the maximum index is 4. Now, see, a of 0, let me just take this. All right, so if you can see here, I defined a of 5, okay, equal 5, 7, 8. But here I have 5 elements, right? While what I provided is 3 elements only. So what will happen? Actually, the program will assume that you mean that the rest are zeros, okay? And it adds zeros from its side. All right, so it will consider that 5, 7, 8, 0, 0. Okay, so a of a, this cout a of a will print 5, a of 0. A of 1 will print 7, a of 2 will print 8, a of 3 will print 0, and a of 4 will print 0. Because this is 0, 1, 2, 3, and 4. So usually, if you don't provide any or initialization to the array, it will take 0. Okay, Let's get back to the program and see the result. All right, so if you can see here, I have 57800. Okay, maybe you noticed that I'm repeating the same instruction. Let me just first share it with you, or put it in the presentation. So just to remember this, okay. Comment without using counters, okay, or iterations, or iterations. Okay, so what does that mean? Let's see how to solve this. That means if I'm not going to use a counter or iteration, that means I need to use 1000 instruction if I have an array with 1000 element, right? Which is not a reasonable way. So let me just share this with you, and then I'll show you how to use the counter. This is without using iterations or counters. Now, if you notice this, again, I'll take it and try to explain to you like aside. All right. Now, if you can see this, I'm repeating the same instruction, right? But what is the difference between all these instructions is this: 0, 1, 2, 3, and 4. Now, if I create a counter that counts 0, 1, 2, 3, 4, and remember the counters, we studied them by using for integer I equals 0, I less than 5 or less than or equal 4, I plus plus, and then here our print C out A of what? Of I. Okay. That means I can use the same instruction, okay, but we'll repeat it continuously until I reach the last index, right? So let's try this, and here instead of writing this, again, please just pay attention here. For integer I equal from where? From 0. Why? Because the indices start from 0. I less than or equal 4. Actually, it should be less than or equal 4. But for me, I would prefer easier to be less than the size of the array. Okay, less than 5 and I plus plus. All right, now here, what I'll do, see, I don't need to have all this number of instructions. Because the same instruction is repeated to 0, 1, 2, 3, 4. So I'll compensate all of these by adding here I. Okay, and remove the rest of the instructions. Okay, so this is what we got. Now I have I will go from 0, will iterate from 0 to 4, to 5 through 4, all right? And the same instruction will be executed every time I'm calling here. When I have I equals 0, then C out A of 0. When I have I equal 1, then C out A of 1, and so on. Of course, to reach 4 maximum. So if I execute this here with using counters or iterations. All right, then let's run it. Okay, the same result, 57800. Okay, now any operation, any processing you want to do, just let me share this with you. This with using counters or iterations. All right, the same function, if you can see here. Here printing. This example is printing the contents of an array. Here, if you can see, for integer I equals 0, then I have I, and I have A of I, and the C out. Now, when I is 0, that means for I, it will execute this. Then C out A of I is equal to 5, correct? Then the output will be 5. Now, it will go back again and take the next I, which is 1. Then I is 1. A of 1 here is equal to 7, and it will print 7. And again, it will go back. 2. A of 2 is equal to 8, correct? And it will print 8. 3. It will go again and check that I have 3. All right. Then A of 3 is equal to what? 0, right? 0, print 0, and 4, 0, 0. Now, when it becomes 5, it will not execute it because I less than 5. It will not reach 5. It will stop at 4. All right. Okay. Now, passing an array to a function, we'll take example in advanced discussion, but let us discuss this. Now, if you remember when we passed functions, when I say integer function of integer x, and then here I say x equal or return x times x. This was the square function, right? Now I passed parameter x here, but can I pass array? That means a lot of parameters. Of course, yes, but with one constraint. Now to pass an array declared as integer my array, this is an example of 25, to function, my function, a function call would reassemble, and my function, this is the way, in other words, okay, my array and 24. Here you need to pass, for example, let's call it integer, okay, a function of array name, comma, size. You cannot pass only the array directly. You have to pass the array name and the size of the array. So if you want to pass this array to a function, then you have to pass the name of the array and the size of the array. This will be discussed thoroughly soon. So array size is usually passed to a function. This is one of the constraints and limitations of using array in C++ with functions. All right, array passed call by reference. Now this can be overcome when we will talk about pointers. Okay, so value of name of array is address of the first element. Function knows where the array is stored. Also, if we pass, for example, the pointers, when we talk about the pointers, maybe you saw this notation somewhere, star p, okay? We will show that I will tell the function that the array starts here, all right? And it will continue till I reach the final or the last element. Okay. In other word, or another way of passing argument is to pass the array as I told you. For example, here, when I say my array of 3, I'm not passing an array, I'm passing an element. As I told you, you deal with the array elements as individual variables, just like what we did before here. A of 0, A of 1, A of 2. Okay, so you can deal with them as individual variables, but you cannot say, for example, C out A. Okay, you will get error. Why? Because A is an array and you have to identify the index. Okay, all right. So write a program that does the following. This example. Define an array that consists of 6 integers. Print the first element of the array. Print the fourth element of the array. Print the last element of the array, and print the entire array using for loop. Okay. If you understand this and you know how to work with it, then I think anything related to array will be a bit easy. So define an array that consists of integer A of 6. Do I need to declare or to initialize it? Yes, okay. I will initialize it. Otherwise, I can give it only 0 until I'll take all zeros. For example, here I have 5, 4, 1, 6, 13. How many elements? 1, 2, 3, 4, 5, and 37. Okay, that means A of 0 is 5, A of 1, 2, 3, 4, 5. Okay, now remember that you need to know the number of the elements. All right, now the second part is print the first element. Always see out A of 0. First element always start with 0. Print the fourth element. See out A of 4 minus 1, 3. Always subtract 1. When I say fourth element, that means the index is 3. All right. Print the last element of the array. See out A of. What's the size of the array? 6. Last element is 6 minus 1. That means 5. Okay. Print the entire array using loop. Of course, in this case, for integer I equals 0, I less than 6, I plus a plus. We did it already. Here, C out A of I. All right. So let's implement this one by one. So I'll start implementing this. I'll define the array, or I'll take the full example. All right, I'll define the array here. Integer A of 6. You can leave it like this, but it's better to initialize it. If you don't know the values, then it's better to write 0 here. All right, that means all the elements will be zeros. But here, as we said, I'll consider 4, 5, 12, 14, 45. How many elements we have now? 1, 2, 3, 4, 5. Then I have the sixth element, 87. All right. Don't forget the semicolon. Now, print the first element. Place is C out the first element is of what? Of 0. Okay. The third element, C out the third element is I think it's required the fourth, right? The fourth, all right. Element is A of, actually it's 4 minus 1, right? You can write it like this, or you can write it of 3, whatever you prefer. Okay. The last element, C out. Last element is also the same way. You can put it A of 6 minus 1, all right? Or you can put it as 5. That's it. Now the last point is to print the entire array. Of course, here we need to put end lines so to avoid having everything in one line. The last thing is to use the for loop to print everything, for printing the entire array. So for integer, I equals 0, I less than 6, I plus plus. Okay, and here, you know, you don't need, since you have only one instruction, you can write it directly, C out, because it's one instruction, right? Remember this, C out A of I equals A of I. All right, so I'm done. Let's run it and see. Successfully, all right, then start debugging. Okay, I have here, I need to add some space. Just allow me here to add space between the arrays or end line. DL, all right. Okay, run. Perfect. So if you can see here, the first element is 4, the fourth element is 14, the last element is 87. If you notice that here, I printed it like this. This is the common way of printing the array. It's not necessary to be the only way, but I like to print it like this. So A of 0 is equal to 4, A of 1 equal 5, A of 2 equal 12, A of 3. That means 4, 5, 12, 14, etc. So we printed everything. Now I'll share this with you. Okay, I think I already shared it in the lecture. Yeah, all right. So this is available here. And please, I want you to implement this code. Okay, whatever code we discussed today, I want you to implement them. And by the way, Sunday you will be having a quiz. All right, I'll put it in the calendar now. Sunday. Okay. Okay, so Sunday, I'll put it in the calendar. You will be having a quiz. Okay. The quiz will cover the functions and the arrays. Yeah, the arrays also. Okay. Well, I'm done. Do you have any questions? Seems that you don't have. Please read it carefully. And if you have any questions, don't hesitate to ask. We'll discuss